Welcome to Month 4 of the BISTEC Hearts Academy DevOps Architect Track, Multi-Cloud and Hybrid. Where Month 1 was the Architect Lens and Month 2 was the Platform Team Lens and Month 3 was the Security Architect Lens, Month 4 is the Multi-Cloud Lens, the discipline of deciding when multi-cloud is the right answer, and the architecture to make it work when it is. The premise of Month 4 is simple. Most platforms drift into multi-cloud by accident, an acquisition, a regulatory customer, a workload class that one cloud does better. The default reaction is to abstract everything so the platform can run anywhere. The honest reaction is to name the forcing function, name the boundary, and not pay portability tax for portability you will never use. The job of the multi-cloud architect is to choose the cloud, not to escape it. The 4 learning objectives today. First, decide between multi-cloud, hybrid, and single cloud with portability and defend the call in writing. Second, architect a cross-plane control plane that abstracts portably without lying about the leaky abstractions. Third, design cross-cloud network topology, transit, DNS, identity, with the topology that matches the workload reality. Fourth, author a cost, performance, and blast radius trade-off matrix with real numbers, not feelings. 4 hours, 4 artifacts. Each one is a piece of paper you can take to a funder, a CTO, or your own team on Monday morning. Let us get into it. 4 hours, 4 artifacts. Hour 1 is strategy and trade-offs. Why multi-cloud is real, why it is not, and the decision tree that ends the let us go multi-cloud reflex. Lock-in versus lock-out. Pick your poison and write down why. Hour 2 is cross-plane as control plane. The anatomy of providers, XRDs, compositions, and claims. The portable database abstraction and where it leaks. The composition trade-offs, one composition across clouds, per cloud compositions behind one XRD, or cloud-specific XRDs. Each pattern has a constraint. Pick the constraint that matches your portability promise. Hour 3 is the architecture challenge. You will author a cross-plane composition exposing a portable abstraction. Sketch the cross-cloud network topology, transit, DNS, identity. Pair share at the end. Present the leaky abstraction you named, the contract you constrained, the off-road escape hatch you designed. Hour 4 is network, identity, and cost. Transit topology, hub and spoke for most, full mesh when justified, direct interconnect when the commit is cheaper than the egress. DNS across clouds, split horizon private zones, resolver endpoints. Identity, SPIFFE and Aspire for portability, federated to each cloud's EAM for cloud-native permissions, and egress cost, the silent line item that destroys multi-cloud ROI. The 4 artifacts you walk out with are: a multi-cloud strategy and decision rationale, 25 points, a cross-plane composition plus design doc, 25 points, a cross-cloud network topology, 25 points, and a cost, performance, blast radius matrix, 25 points. Hard rules. The decision tree skipped is -10 on artifact 1. A leaky abstraction unnamed is -10 on artifact 2. A resolver SPOF, unnamed is -10 on artifact 3. An egress audit missing is -10 on artifact 4. The decision tree. Most teams answer this reflexively. The right answer is almost never yes. Walk the tree in order. Number 1. Does a regulator or customer require 2 clouds? If yes, multi-cloud contained only the regulated workload. Do not migrate everything to satisfy one regulated customer. If no, continue. Number 2. Are M&A or acquisition plans pinning you to a second cloud? If yes, hybrid, manage it, plan the sunset. Acquired cloud is a debt, not a strategy. If no, continue. Number 3. Is cloud materially better for a workload class you care about? If yes, use it. Portability later if needed. Do not pay the abstraction tax for a future you might not reach. If no, continue. Number 4. Default. Nothing forced you to multi-cloud. Pick one cloud plus a portability discipline, Kubernetes, OpenTofu, cloud-agnostic primitives. Buy replaceability at the boundary, not parity across providers. The takeaway. Multi-cloud is a forced outcome, not an aspirational one. If no regulator, no M&A, no workload class is forcing it, the cheapest answer is one cloud and a portability discipline. The decision tree exists because the reflex answer is wrong. Multi-cloud has reasons. Most of them are not because we might want to. The cost is real. The resilience is partial. Reasons that are real. Regulatory. Data residency sector regulation, finance, healthcare, public sector, that pins workload to a jurisdiction. This is a force function, not a preference. The platform runs in two clouds because the regulator said so, not because the architect thought it would be nice. M&A. Acquired company is on another cloud. The integration is bounded. Sunset is a roadmap item. If you cannot name the sunset date, the acquired cloud is a permanent cost, not a temporary debt. Workload fit. One cloud has GPU pricing or a managed service that materially shifts the unit economics of one workload class. The decision is per workload class, not platform. Do not migrate the workload that does not benefit. Negotiating leverage. 2 committed spend contracts is a real lever. Use it. Do not architect around it. Reasons that are not. Best of breed. Picking the best service from each cloud is the lowest common denominator anti-pattern. The integration cost eats the feature delta. The portable platform that exposes only what every cloud has in common is paying multi-cloud cost for single cloud capability. Avoid lock-in. Lock-in versus lockout. The second is often worse. Cloud-agnostic primitives are replaceability, not feature parity. Aspirational portability is more expensive than honest lock-in. Cost. Egress is the killer. Cross-cloud traffic is internet priced. Multi-cloud HA patterns multiply the bill. Talent. One cloud done deeply beats 2 clouds done shallowly. We support both means we support neither well. The takeaway. The cheapest resilience is one cloud done well in 2 regions. Multi-cloud is for the workloads that have a forcing function, not for the workloads that do not. Lock-in is what you pay to use a cloud's strongest features. Lockout is what you pay when you refuse to pay any. Pick lock-in when the workload is core, the cloud's managed service materially shifts the unit economics, and switching later is a price you accept. Lock-in has a boundary. Wrap it in a composition or a Terraform module, so migration is bounded, not whole platform. You have negotiating leverage. Committed spend with one provider is real leverage. Do not fragment it for a portability you will never use. And the lock-in is cost-honest. You have named the cloud-specific features you depend on, and the price of the lock-in is lower than the price of the abstraction tax. Pick lockout when the workload is commodity, stateless API, container, queue and runs on any cloud. Portability is cheap. You cannot name what is different. Cloud agnostic with no concrete cloud-specific feature in use means the abstraction tax is paid for nothing. The goal is replaceability, not parity. Can leave in a quarter is a much lower bar than identical API on every cloud, and a much cheaper one to meet. And you have boundary discipline. The cloud-specific pieces are wrapped at the perimeter, and inside the boundary the primitives are cloud agnostic. The takeaway. Cloud agnostic is a claim. Name the cloud-specific features you actually use. The decision is not lock-in or portable. The decision is lock-in here, lock-out there, and a named boundary in between. Hybrid is not a destination. Each pattern has a forcing function and a sunset trigger. If you cannot name both, the pattern is accident, not architecture. Pattern 1. Bursting. Use a secondary cloud to absorb overflow during peak. Stateless workers, batch jobs, image processing. The cost is paying for 2 control planes. double the egress budget. Cheaper than peak provisioning, more expensive than steady state. The sunset trigger is steady-state capacity planning that absorbs peak on one cloud. Without a sunset, bursting becomes a permanent cost. Pattern 2. Regulator-pinned. Use it when data residency or sector regulation forces workload to a specific region or provider. The integration is bounded. The pinned workload runs on its native cloud. The rest of the platform is one cloud. The cost is the integration itself, not the steady state. The sunset trigger is rare, the regulator is the forcing function. Plan for it, do not fight it. Pattern 3. M&A-stuck. The acquired company runs on another cloud. Integration takes quarters. Migration is a roadmap item. The cost is 2 engineering cultures, 2 runbooks, 2 cost centers. The integration window is the expensive part. The sunset trigger is a named date when the acquired workload is migrated to the platform cloud. Without a named date, the debt compounds. The acquired cloud becomes the second cloud you never wanted and can never leave. The takeaway. Every hybrid pattern has a forcing function and a sunset. If you cannot name both, the pattern is accident, not architecture. Accidents do not get sunsetted. Crossplane lets Kubernetes be the API surface for everything. The composition contract is the boundary, not the provider. The pieces, providers, one per cloud or service, AWS, Azure, GCP, Equinix, Datadog. Each is a CRD set exposing native resources. XRD, composite resource definition, the platform's own API. What an application team sees. The boundary of the contract. Composition, the implementation behind the XRD, maps XRD fields to one or more managed resources. This is where the cloud-specific work lives. Claims, namespaced usage of the composite. Application team creates a claim, the platform reconciles it. They never see the cloud's API. Where the work happens. Boundary discipline. The XRD is the contract, portable, versioned, owned by the platform team. Application teams see only this. The composition is the implementation, cloud-specific. It can be one composition per XRD, portable but constrained, or per cloud, powerful but committed. Provider versions matter. A provider upgrade changes the managed resources. Pin, test, gate the upgrade. Drift is the failure mode. The composition contract is the paved road. Anything outside the contract is off-road. By design, not by accident. The takeaway. Crossplane is not a cloud abstraction library. It is a control plane with a contract. The XRD is the API you promise. The composition is the cost of the promise. Be honest about which is which. The most seductive abstraction. The most honest test. Where does it leak, and what does the leak cost? What the XRD promises. Postgres compatible. Connection string, version, size, replicas backups, point-in-time recovery, application visible. The application sees a standard Postgres endpoint. No cloud-specific calls in business logic. Operational SLA. The platform promises uptime, RPO, RTO. Application teams consume the SLA, not the implementation. Day 2 surface, upgrade, scale, snapshot. Restore are all in the contract. Application team does not page the platform for them. Where it leaks. Managed features. AWS RDS EAM Auth, GCP Cloud SQL EAM, Azure Entra. Different APIs, different auth flows. Pick one, or require password only. Performance knobs, parameter groups versus flags versus server parameters. Cloud-specific names, same SQL underneath. The XRD must constrain to portable knobs. Extensions, PostGSP vector, PG-stat statements. Some clouds bundle them, some do not. The contract names which extensions are paved. Migration cost. The database is the highest cost asset to migrate. The portable XRD lowers the migration cost, not to zero. Name the residual. The takeaway. Every abstraction leaks. The job is to name the leak, constrain the contract to the portable surface, and document what happens when an application team needs the non-portable part. Off-road is a feature, not a backdoor. 3 patterns for composition. Pick the one whose constraint matches your portability promise. Pattern A1 composition, multi-provider switch. Same composition, different provider config per environment. The XRD is portable. Provider choice is environment scoped. Pro, truly portable contract, 1 composition to maintain. Con, lowest common denominator features, weakest cloud-specific capability. The portable promise costs you the cloud's strengths. Pattern B, per cloud composition behind same XRD. Same XRD schema, different composition implementation per cloud. XRD constrains the contract. Each